Good day. In this video, we will be doing the answers to assignment 12. So let's get cracking. Question 1. Let E be the solid enclosed by the parabolic cylinders y equal to 1 minus x squared, y is equal to x squared minus 1, and the planes x plus y plus z equals 2, and 2x plus 2y minus z plus 10 equals 0. Alright, so E is a blob in R3, and we want to express the volume as an iterated integral using both orders, and then we want to find this value. Alrighty, now to help us understand what the solid E looks like, on the left I've sketched the parabolic cylinders y is equal to 1 minus x squared and y is equal to x squared minus 1. So you can see they enclose a region in the middle, not quite a cylinder, but they enclose a region in the middle. Alright. However, it doesn't have a top and a bottom, so it doesn't have a lid. And this is why we have these additional planes, all right? So if you look at the first plane, you can rewrite this as z equals 2 minus x minus y. And you can rewrite the second plane as z is equal to 2x plus 2y plus 10. And you can see in the diagram, the red axis is the y-axis, the green is the x-axis, and the blue axis is the z-axis. If you take the solid and project it on the xy plane, the x values and the y values are pretty small, all right? And so, when z is equal to 2x plus 2y plus 10, this will be the top lid, and when z is 2 minus x minus y, this will be the bottom lid. All right, so you can see that the solid is indeed enclosed on all sides. All right, so it lies between these parabolic cylinders, and the top plane is given by z is 2x plus 2y plus 10, and the bottom plane is z is given by 2 minus x minus y. So let's quickly write that down. So let f equal to the top, which is 2x plus 2y plus 10. Let's just say this is the top in brackets. And let g equal to 2 minus x minus y. This is the bottom surface. Alright, now we are interested in if we take the solid E and we project it to the xy plane. So let's make a heading. Let's call it the shadow. So if we look at the shadow in the xy plane, you can see it lies between these two parabolas. The one is y is equal to 1 minus x squared. The other parabola is y is equal to x squared minus 1. You can see they both cut the x-axis at minus 1, 1. The one parabola cuts the y-axis at 1, and the other parabola cuts the y-axis at minus 1. So they enclose this region D, and this is the shadow on the xy plane. Alrighty. So now we have a rough idea what the solid looks like, and we know what the shadow of the solid on the xy plane looks like. And now we're in business, because now we can tackle part A. So we want to write the volume as an iterated integral with order dy dx. All right? So we can say that the volume of E is a double integral of over the shadow or the projection on the xy plane, which is region D, of the top surface minus the bottom surface dA. So using that result on page 134. Alrighty, and now we know what the top surface is. That is 2x plus 2y plus 10. We know what the bottom surface is. That's 2 minus x minus y. And we have to use the order dy dx. So that means we are shooting vertical bullets. Alright, so if you draw vertical slices, you can see it always starts on the green parabola and it always ends on the blue parabola. So you see there's no need to split up the region. So what we're going to say, it's a double integral. The smallest x value is minus 1. The largest x value is 1. And where does y start? It starts on the green parabola, which is when y is equal to x squared minus 1. And it ends on the blue parabola, which is when y is equal to 1 minus x squared. And if you simplify the integrand, you get it as 3x plus 3y plus 8, and the order is dy dx. And that is the answer to part A. we've written the volume as a double integral, as an iterated double integral with the order dy dx. Alright, now let's move on to part B. So we want to do the same, but this time around we want to have the order dx dy. So if we're having dx dy, now we are shooting horizontal bullets. Now you can see if you're below the x-axis and you shoot a horizontal bullet, it starts on the green parabola and it ends on the green parabola. However, if you shoot a horizontal bullet above the x-axis, it starts on the blue parabola and it ends on the blue parabola. So you can see you need to split up the region into D1, which is below the x-axis, and D2, which is above the x-axis. Alright? So now if you look at the green curve, which is where if you shoot a horizontal bullet or a horizontal slice on D1, you will see that x squared is y plus 1, so x is plus minus the square root of y plus 1. So this is the green parabola. And if you look at the blue parabola, you see that x squared is equal to 1 minus y, so x is equal to plus minus the square root 1 minus y. The minus will tell you where it enters, and the plus will tell you where it leaves. Alright? So if we're going to express the volume using this order, we're going to write this as a double integral over d1, which is below the x-axis. The integrand is still 3x plus 3y plus 8 dx dy plus a double integral over region d2. The integrand is still 3x plus 3y plus 8 dx dy. Alrighty, and now let's go for it. So let's describe d1. d1 is the bit below the x-axis. Alright, so below the x-axis, the smallest y value is minus 1 and the biggest y value is 0. Alright, and now we got to say, okay, if we shoot a horizontal bullet or we draw a horizontal slice, where does it start and where does it end? So it starts on the green parabola and it ends on the green parabola, which is this plus minus square root y plus 1. So it starts with the minus root and it ends at the plus root. And the integrand is 3x plus 3y plus 8 dx dy. And now let's do region D2 as an iterated integral. So the y value start at 0, end at 1. Alright? If you shoot a horizontal bullet, it starts on the blue curve and it ends on the blue curve. Alright? So it starts when it's minus root 1 minus y, and it ends when it's equal to root 1 minus y. The integrand is still 3x plus 3y plus 8 dx dy. And that is the answer to part B. So you now had to write it as a sum of two iterated integrals because we had to split up the region. Alright, and then in part C, we need to calculate it. So now we have two choices. We could take the single integral in A, or we can take the two double integrals in B. So if I have a choice between doing one double integral or doing two double integrals, I would rather do the single double integral, alright? But you're welcome to do B, but I'm going to let you to do A. So you work your way from the inside to the outside and you do it. Right? And see that you agree with me that the volume of E works out numerically as 64 over 3 cubic units. Alright? If you didn't get this answer, keep trying until you get the value of 64 over 3. Alright? So that was a nice little exercise. We had a solid and we turned it into iterated integrals. And using the iterated integrals, we could calculate the volume of the solid. Alrighty, let's move on to the last question, which was question 2. So we have a function of two variables. It is 2x plus 4y. R is bigger than 0, and D be the square with vertices 0, 0, R, 0, 0, R, R, R. Now in part A, we need to fully explain why there is always at least one P, all right, at least one P such in the region D such that FP is equal to the average. So obviously we're going to use a theorem. What theorem are we going to use? We're going to use the mean value theorem for a function of two variables, all right? But A is a theoretical question. So you need to address this by making sure why can you use the mean value theorem for a function of two variables. So you need to verify that all the conditions are met, all right? So let's start and say, all right, let's look at what region D looks like. So let's quickly draw region D. So I have the x-axis, I have the y-axis. And it is a square with vertices 0, 0, r 0, 0, r, r, r. Alright, this is region D. Alright, now this region is very special, alright, because this region has a lot of properties, alright, and we can say it. D is closed and bounded and path connected. Very important, all right? You have to mention all three. So D is a closed set, D is a bounded set, and D is path connected, all right? And now F is continuous on D. If you want to have a reason, you can say F is a polynomial of two variables. Remember one of the exercises we did in the tutorials, we proved that if you have a polynomial of two variables, it is continuous everywhere. So don't just say F is continuous, say F is continuous on region D. All right? And now if you look at theorem 151 on page 139, these are all of the conditions. And so we can say by the mean value theorem of a function of two variables, there is a P in D such that the average is attained. So if you evaluate F at the point P, it is equal to F average. All right? So we got to address why we can use the mean value theorem. So we need to satisfy all of the conditions of the mean value theorem. All right, so not a calculation, but a theoretical explanation of why you can always find a point P in region D with this property. All right, and now let's do the fun part. Now, in part B, we need to find R, all right, so the size of the square, if P is equal to this specific point and it satisfies the property that FP is equal to F average. All right, now not everybody has the same alpha, but I'm going to do the following. I'm going to, for today's video, I'm going to take alpha is equal to 1. So P will be the point 1 plus 4, 1 plus 1, so that will be the 0.52. All right, so you could have had a different alpha, but I'm taking alpha equal to 1, so I am taking the point, if my alpha is 1, I have the 0.52. All right, and so remember we know what the function is. It's 2x plus 4y. So let's have a look at what FP is. So FP is F52. So this is 2 times x plus 4 times y. So it's 10 plus 4. That is 18. So FP works out to be 18. Alrighty. Now, we know that F at the point, if my alpha is 1, is 18. Alright, so now let's work out F average. Alright, now to work out F average, you need a lot of things. Alright, you need the area of the region. So it's a square of size r, so the area would be r squared. And now we know that the formula for f average is 1 over the area over region D, the double integral over region D of f dA. Alright, so let's quickly do this double integral. So the area is 1 over r squared, and now D is a square, so you can shoot vertical or horizontal bullets, and so it doesn't really matter. I'm going to say, alright, the function is 2x plus 4y, and I'm going to take the order dy dx. So the range of x is from 0 to r, the range of y is from 0 to r. Okay, let's do this maths. So 1 over r squared, we integrate from the inside. So the integral of 2x becomes 2xy, the integral of 4y becomes 2y squared, the bottom bound is 0 for y, and the top bound is r for y dx. And so it is 1 over r squared. If I plug in y naught, I get naught. If I plug in y's r, I get 2rx plus 2r squared. Alright, dx. Now it's a single integral, and now I integrate 2rx, that becomes rx squared, that becomes 2r squared x. The bottom bound is naught, the top bound is r. If I plug in naught, I get naught. If I plug in r, I get 1 over r squared times r cubed plus 2r squared times r. So I end up getting 3r cubed over r squared. So that evaluates to 3r. Alright, so f average is 3r. Alright, and so now it's given that fp is f average. F average we worked out to be 3r. fp we worked out to be 18. So that means that therefore r is equal to 6, and that is the answer if your alpha was equal to 1. Alright, this is the end of the video. I hope you enjoyed the explanation and have a lovely day. Cheers!